Hi class, welcome to exercise 3C, multiplying and dividing surds. Just like our previous lesson, this is going to be a small extension of our first lesson about surds, and hopefully will also be a quick video. But once again, there's actually a fair bit of pre-learning for you. So let me introduce the examples and the pre-learning. In example 6, we're going to be simplifying a product of two surds. And your pre-learning in this is questions 1, 2, 5 and 6 for the new book. So that's quite a lot there. And questions 2 and 5 in the old book. Then we'll do example 7, where we'll be simplifying surds using division. And your pre-learning is questions 3 and 7 in the new book and questions 3 and 6 in the old book. And our final example for this class is example 8, where you'll be using the distributive law. And the pre-learning for this is question 8 in the new book and question 7 in the old book. And just like the last class, this will be very straightforward for some people, particularly those who have sat in a pre-methods class prior to this. So by all means, skip to the end, check the learning intentions, do the pre-learning, I'm happy with that. But for those of you who hang around, you're going to see in this lesson that surds have something in common with fractions. And that is that unlike whole numbers, they're easier to multiply and divide than they are to add and subtract. Alright, let's get on with the introduction. For this topic, there's only a few concepts you need to know, and we've already covered them. So let's write them down now for those of you who need to take notes. So the first thing to remember is that the square root of x times the square root of I is equal to the square root of x times y. And that's just by using index law 4, because we already understand that the square root is just raised to the power of a half. So that's the same as saying x to the power of a half times y to the power of half is equal to x times y to the power of a half. And that the square root of x divided by the square root of y is just equal to the square root of x divided by y. And we learnt that with law 5 of the index laws, because that's the same as saying x over y to the power of a half is equal to x to a power of a half divided by y to a power of a half. And just to be sure that you're very confident with some common mathematical concepts, we need to remember what associativity is, which is just saying when we multiply things together, it doesn't matter what order we multiply them together. And that's because multiplication is associative. So anything that we say is associative, we can do it in different orders. So when it comes to square roots, we could say that if we had a times the square root of x times b times the square root of y, then we can rejig the order and make that a times b times the square root of x times the square root of y. So that's the point that it's associative. And of course that can then become a times b times the square root of x times y. And that's just using law 4, right? And we can use something similar with fractions. So if we said a divided by b multiplied by the square root of x divided by y, well, we could just move in the opposite direction that we did with law 5. So then it becomes a divided by b multiplied by the square root of x divided by the square root of y. And when we multiply fractions together, we just multiply the numerators and the denominators, and then we'd end up with a times the square root of x times b times the square root of y. And when we state these rules here with algebra, because they're equal signs, you can move backwards and forwards, whatever's the most convenient for you to simplify your expression the best you can. All right, we have one more fact in the introduction, and that is using the distributive law with surds. So just like we do with numbers, i.e. a times b plus c equals a times b plus a times c. In other words, we multiply the a by each element in there and we keep the plus or minus sign, whatever we see. Then no surprises, it's going to be exactly the same for surds. So if I use an example with the square root of x times a plus the square root of y, then I just multiply the square root of x times a, and that will give me a times x. Sorry, the square root of x. And then I would multiply the square root of x with the square root of y, just like I did with a times c above that. So the square root of x times the square root of y, at this stage we'll just write that out as plus root x times root y. And we can't simplify the a times square root of x, but we could rewrite the square root of x times the square root of y as the square root of x times y. Alright, and so you can use the fact that these are all equals to signs, so you might want to simplify from the second line to the first line in this case. Depends what we see in our examples. Speaking of which, let's finish this introduction now and move on to our next section. When we're going to simplify a product of two surds, we can use just what we already know. So there's nothing really for me to add here, so let's just get straight into example 6, where we'll simplify the following expressions. Okay, in part A, we've got the square root of 2 times the square root of 3. All right, this is really straightforward, right? We know how to multiply two surds together. We just end up with their multiplication inside the surd. So 2 times 3 is 6. So this is equal to the square root of 6. Done. And we could just say that's by law 4. Okay, in part B, the expression is 2 times the square root of 3 times 3 times the square root of 15. All right, so let's use our friend associativity. 2 times 3 is 6, and 3 times 15 is 45. So just to make sure you're confident, I'm just going to draw some arrows here. In fact, I'm going to get rid of them. They're a bit messy. All right, but hopefully you understand that 3 times 15 is 45, and 2 times 3 is 6, and that's why we are where we are. Now let's simplify this surd, because I can see there's a perfect square in there. In fact, we did this in our last exercise. So 45 is equal to 9 times 5. 9's a perfect square. So this is now equal to 6 times the square root of 9 times 5. And I'm doing that because we do have a perfect square factor. So let's get it out of there. Square root of 9 is 3. So 6 times 3 is 18. So we now have 18 times the square root of 5. I can do those two intermediate steps on the side here to make sure everyone's confident. So the 6 times the square root of 9 times the square root of 5, using our multiplication rules with surds, right? And then we end up with 6 times 3 times the square root of 5. And 6 times 3 times the square root of 5 brings us back to 18 times root 5. All right, let's move on to part C, where the expression is 2 times the square root of 5, all squared. So using our index law 4, that's going to equal 2 squared times the square root of 5 squared. And you should know by now that the square root of 5 squared is 5, right? So that's now equal to 4 times 5, which equals 20. You need to be sure of the fact that the square root of x squared is equal to x. And hopefully there's no doubt in your mind that 2 squared is 4. Anyhow, the first example is just this simple, but there is a lot of pre-learning, so pause the video now. And if you have the new book, you need to do questions 1, 2, 5, and 6. And if you have the old book, you need to do questions 2 and 5. All right, that's the end of that section. I'll see you in the next one. All right, we're going to simplify surds using division. If you can remember that a divided by b is equal to a over b and index law 5, then you'll have no problems at all in this section. So without further ado, let's move on to example 7, where we're going to have to simplify these surds. In part A, the expression is minus root 10 divided by root 2. So using our tricky division fact, that's equal to minus root 10 over root 2. And if we leave the negative sign out the front, we can now use index law 5. And if we leave the minus sign out the front, we've now got minus root 10 over 2. And 10 divided by 2 is 5, so that's just equal to minus root 5. Okay, it's that simple. So let's move on to part B, where they want us to simplify 12 times the square root of 18 divided by 3 times the square root of 3. So I'm just going to go backwards what I normally do when I've got two fractions and turn this into two fractions. So that's going to equal 12 on 3 multiplied by the square root of 18 on the square root of 3. And I hope you can see why I did that, because 12 divided by 3 is 4, so that's nice and easy. And then using law 5 of the index laws, that becomes the square root of 18 on 3. And 18 divided by 3 is 6, so that's equal to 4 times the square root of 6. And it's just that simple. All right, so seeing it's that simple, pause the video now and work on questions 3 and 7 in the new book and 3 and 6 in the old book. And then come back and I'll see you in the next section. Using the distributive law with surds is no different to using it with any other real number. So as long as we know all our rules about multiplying and dividing surds, this won't make a difference. So let's just get straight into example 8, where we're going to use the distributive law to simplify these expressions. Okay, in part A, the expression is the square root of 3 times 3 times the square root of 5 minus the square root of 6. So step 1, I'm just going to use the distributive law. So I'm going to multiply each number in the brackets by the square root of 3. So therefore we get 3 times the square root of 3 times the square root of 5 minus the square root of 3 times the square root of 6. And using index law 4, 3 times 5 is 15. So we've got 3 times the square root of 15. And 3 times 6 is 18. So we have minus the square root of 18. And we can actually simplify that because there is a perfect square factor of 18, that's 9. So 3 times the square root of 15 can't be simplified anymore. but 18 is equal to 9 times 2, so we've got minus the square root of 9 times 2. And the square root of 9 is 3, so I'm going to skip to writing that as 3 times the square root of 15 minus 3 times the square root of 2. And that's as far as I can go with simplifying. The only other thing I might do is factor the 3 out, but who cares? Just leave it as 3 times the square root of 15 minus 3 times the square root of 2. Alright, let's go on to part B, where the expression is 3 times the square root of 6 times 2 times the square root of 10 minus 4 times the square root of 6. Alright, so the 3 times the square root of 6 has to multiply each element inside the brackets. And seeing we've already done these sort of steps in the first couple of examples, I'm going to skip a few steps, so to speak, here. So our first bit has a 3 times 2, which makes 6, and the square root of 6 times the square root of 10 makes 60. So we can write that out as 6 times the square root of 60. And then for the next bit, we have 3 times 4 is 12, and 6 times 6 is 36, so we get minus 12 times square root of 36. Alright, hopefully you all know that the square root of 36 is 6. Maybe I wasted my time writing the square root of 6 times the square root of 6. But anyhow, 12 times the square root of 6, which is 6, is equal to 72. Okay, so that's 12 times 6. I can simplify this surd on the left because 60 is 4 times 15. So that's equal to 6 times the square root of 4 times 15. Always looking for that perfect square to simplify our surd. So the square root of 4 is 2. So we're going to end up with 6 times 2 is 12 times the square root of 15. Minus that 72. And we can't simplify that any further. Alright, I'm pretty confident most of you will find this fairly easy. So pause the video now and work on questions 8 in the new book and question 7 in the old book. And I'll see you back in the summary. Okay, this lesson has a lot of pre-learning, but I'm expecting those who've completed everything up to this stage will find all of that fairly simple, and I'm hoping for some very high self-ratings in class. But anyhow, to consider this lesson a success, you will know how to multiply and divide surds. Understand that by definition, the square root of x times the square root of x is equal to x, and this can be helpful in simplifying multiplications. And able to apply the distributive law to brackets involving surds. Okay students, have a good day, enjoy this lesson, and I'll see you in class or the next video. Bye.